What's up, guys? We're going to do some equations with logs and natural logs in it. I'm going to start with this equation right here and walk you through it. Alright, when we start here, we use the product property, which means if we have a natural log or a log minus another natural log or a log, we can divide the two. So now we'll have natural log 7x plus 3 divided by x plus 1 equals natural log 2x. We can use the one-to-one property to eliminate the natural logs, so now we're left with just 7x plus 3 over x plus 1 equals 2x. And then we can just multiply x plus 1 to both sides, so we just eliminate the denominator. And now we have this, then we can just distribute the 2x now to the x and the x plus 1. And then we're left with this. Now we're just going to move everything to one side so we can factor. From there, we are left with 0 equals 2x squared minus 5x minus 3. And our factor, we're going to get x equals negative 1/2 and 3. We plug negative 1/2 back in, and we find right here that we get a 0. Now you can't natural log or log a 0, so our answer was left with 3. We plug 3 back in, it works perfect. So our final answer is 3. Now for this equation, I'm going to walk you through it. It's kind of the same basic idea. We're going to use the product property to solve for this. So we're going to end up with x times x plus 2 equals natural log 63. From there, we're going to distribute and then use the one-to-one to eliminate the natural logs. So we'll have x squared plus 2x equals 63. Now we're just going to move the 63 to one side, and then we're going to factor from there. But when we move the 63, it'll be x squared plus 2x minus 63 equals 0. We'll factor from there, and we'll end up with equals x plus 9 and then x minus 7. So our final answer will be x equals negative 9 or 7. But when we plug negative 9 back into here, we see that we have a negative number in the ln, and we can't solve for that, so that grinds out. And then the 7 goes back in, no negatives, no 0. We can solve for that, that works perfect.
Alright, so now we're going to solve log instead of natural log. So as you can see, it's the same setup as natural log, except it's a log. And anything that does not, I'm sure this has been touched, but anything that does not have an actual set base for log is log 10, just as it's set in the calculator. So we're going to start, we're going to move the logs onto the same side. So we're going to subtract log x minus 2 to the other side. And then we're going to do the same thing we did with natural logs. So if they're subtracted, it can be divided through the same property. So it becomes log x minus 12 over x minus 2 equals 2. So then with logs, what you can do is you take the base, and if you multiply that times the other side, so this is log 10. So when you move it here, you make it 10 squared because of this 2. So if this was a 3, it'd be 10 cubed. And then this log can be eliminated as this becomes 10 squared. So then it's x minus 12 over x minus 2 equals 10 squared, or 100. And then what we're going to do is we're going to do x minus 2 multiplied to both sides to cancel it from the denominator. And we'll have x minus 2 equals 100 times x minus 2. And then when you multiply that out, you'll have x minus 12 equals 100x minus 200. Then you would move common parts together. So you'd subtract the 100 to the other side and move the 12 to the other side. So you'd have negative 99x equals negative 188. And then you would divide both sides by negative 99, and you'd get 188 over 99, or approximately 1.9. So we're going to do the same thing here, and we're going to go through this problem. So you'd start by moving the logs to the same side. So you'd have log 2x minus 6 minus log 2x equals 3. And then because it's subtracted, once again, you can divide. So you'd have log 2x minus 6 over x equals 3. And then you would do the same property. So it would be 2x minus 6 over x equals 2 cubed because it's base 2 and this is a 3. And then you would multiply both sides to get rid of the denominator. And then you would just move common numbers together. So you'd have negative 6 equals 6x, and then you would just divide by 6. You'd have negative 1 equals x. And then when you put that back in, you see that you have a negative here, and you can't have a negative log, so there is no solution for this problem. And then here we're going to move on to a final equation. This is the formula for exponential growth and decay. It is nt equals no times e to the kt. So nt is the final amount, no is the initial amount, k is the rate, and t is the time. So we're going to start with a word problem, and it's after the end of the World Series, and it's saying with vendors selling their merchandise, last day of the World Series, they made $300,000. And 7 days after the World Series ended, they only made $37,000. So the first part of this problem is to find the decay equation. And the second part is to find how much money they make in 4 weeks after the series ended. So we're going to start in red here is the solution A. So you're going to have your initial amount, which is your final amount, which is the $37,000, is equal to the initial amount, or $300,000, times e to the time, which is the final time, which is 7 days, times the rate, which is k, because it is unknown. And then you're going to first divide by 300,000, and simplified, that is 37 over 300 equals e to the 7k. And then you're going to multiply by a natural log on both sides, because when you multiply a natural log on both sides, it cancels out the e of. So then you'll just have natural log of 37 over 300 equals 7k. And then you're going to divide both sides by 7. So your final answer would be the natural log of 37 over 300 equals, or divided by 7, which can be simplified to negative 0.299 or negative 29.9%. So then for B, you would go back and you would fill in for the t to be 28 days, because it is 4 weeks, and your final amount is unknown. So then you would multiply the negative 29.9 times 28 equals negative 837.2, and that is to the e times 300,000, and that ends up being $0. So in 4 weeks, that means that they would be making no money selling the merchandise. So this has been logs and natural logs, as well as the formula for exponential growth and decay. Yay, guys.